NEC section 250.146 specifies that the equipment grounding conductor, or EG, must be run with the circuit conductors. This means the EGC needs to be installed in the same raceway or cable as the phase and neutral conductors from the panelboard all the way to the disconnect. In contrast, NEC section 250.30 A3 provides conditions under which an EGC can be derived from building steel. These conditions are stringent and must all be met to use building steel as the EGC. Firstly, the building steel must be effectively grounded. This means the steel structure itself must have a reliable connection to ground, ensuring it can safely carry fault current. Secondly, the building steel must be in direct contact with the equipment or raceway that needs to be grounded. This direct contact is essential for providing a low impedance path for fault current to flow back to the source. Thirdly, the equipment or raceway being grounded must not have an equipment grounding terminal. This condition is in place because if a grounding terminal exists, the primary method of grounding should be through a dedicated EGC run with the circuit conductors, not the building steel. In the scenario described, the EGC is not run with the circuit conductors from the panelboard to the disconnect. This directly violates NEC section 250.146. Furthermore, while the EGC is derived from building steel at the disconnect, the installation doesn't meet all the requirements outlined in NEC section 250.30. A3. Specifically, the disconnect does not have an equipment grounding terminal. This indicates that the disconnect is designed to be grounded using a dedicated EGC, not relying on building steel. Therefore, relying on building steel as the sole grounding means in this setup is not compliant with the NEC. To ensure code compliance and safety, the EGC must be run with the circuit conductors from the panelboard to the disconnect, as mandated by NEC section 250.146. Using building steel as the EGC is only permissible under the strict conditions outlined in NEC section 250.30. A3, and all those conditions must be met. If the equipment has a grounding terminal, a dedicated EGC is required. The importance of proper grounding lies in providing a low impedance path for fault current. This path allows overcurrent protective devices, such as circuit breakers or fuses, to quickly detect and interrupt the fault, minimizing the risk of electrical shock, fire, and equipment damage. Effective grounding ensures that metallic parts of electrical equipment are at or near ground potential, reducing the likelihood of voltage differences that could create a shock hazard. Building steel can be used as part of the grounding electrode system, supplementing the primary grounding electrodes like ground rods or plates. However, using it as the sole EGC, especially when a dedicated EGC should be run with the circuit conductors, introduces potential safety hazards. In summary, the described installation is non-compliant with the NEC due to the improper handling of the equipment grounding conductor. The EGC must be run with the circuit conductors from the panelboard to the disconnect, and relying on building steel in this scenario violates both NEC section 250.146 and the conditions of NEC section 250.30. A3. Always adhere to the NEC guidelines to ensure a safe and compliant electrical installation.